Hi, everyone. So nice to be here with you all. More than 50 people in the room, many familiar names. So thank you, everyone who's continuously joining this series. I'm so glad that you are here with us. So yeah, for today we have the dangers of price oracles in smart contracts. So I will just get this started, sharing the screen as always. For those who are joining for the first time, I'm Martin. Everybody calls me Tincho. You can call me Tincho. I'm a security researcher at OpenZeppelin. For many years, I've been an auditor as well here. So the idea of this series is always talking about, specific topics, but also covering many general things around what we call secure development, right? So if you have been joining the series, you will have seen that, well, we have already talked about the dangers of token integration. We have talked about the strategies for secure access controls. And today is the day of price oracles. And price oracles, it's a huge topic on its own, and we only have limited amount of time. So we will cover from the basics to more advanced stuff related to specific price oracles in Ethereum. If you want to watch previous recordings of the previous sessions, they are already available in YouTube. So all yours. For today, it might be a little bit longer session. Again, price oracles are a deep topic and there's lots to cover. And even if I'm not going to be covering every single specific thing about price oracles, this session will be pretty packed with lots of content and things to digest. So bear with me. Hopefully we'll make it together till the end. If you need to drop, of course, this will be recorded. But I think it will be so interesting that people will stay with us. For next sessions, we also have additional topics like smart contract upgrades and the perils of low-level codes, and an additional final session that we'll be doing. This is like a 6 workshop session. So additionally, as I always say, and I'm not changing this meme, I always try to share the mindset, right? I always try to talk about, regardless of, well, today we are speaking about price oracles, and in the last one, access controls, and in the previous one, token integration. I'm trying to always be sharing what auditors and code reviewers usually think about, right? The paranoid mindset when we're trying to approach Solidity code. So hopefully throughout this series, I'm always conveying that message to you. But today is about price oracles, right? And countless Solidity contracts, probably already mainnet, have this line of code. It says Oracle get price. And as an auditor, I get super scared every time I see this. And it's just a single Solidity line, and usually super easy to write. But well, there are dangers about this. There are security considerations when we integrate price oracles in our systems. So the idea of the talk is talking about that, right? As always, we will start the session with some triggers. And I will give you 2 minutes just because this is a longer piece of code. And as always, you can go from top to bottom, line by line, take your time, and try to come up with issues, problems, questions, intuitions, things that smell bad, whatever you think that might be problematic in this piece of code. And you can actually start putting together knowledge that we used in the previous sessions, right? So take your time. I will just shut up for 2 minutes, and then we will resume with some ideas.
Martin, can they type their responses?
No, no need to share spoilers with the rest. No, just take local notes in your mind, whatever, and no need to share anything. I mean, you might want to share something, that's perfectly fine if you want in the chat, but the idea is just for you to take your time, look at some piece of Solidity code, and I'm about to share my kind of mindset when I look at this piece of code and some questions that I would ask as an auditor. So let's do some more seconds.
Will you just repeat the question for some people here, please?
There is no specific question, actually. The idea is for people to look at this code and see what issues and problems you can come up with and what questions you can come up with as you are reviewing this piece of code. That's the exercise. But anyway, enough time probably, so I will just continue. Again, you may have fun things, you may have not. It might seem trivial to you, it might seem like super complicated. Let's start with a few, and then we'll get deeper into some Oracle-specific stuff. So as always, we question the code, right? We look at code, we try to be parallel enough, so we are able to come up with a huge list of questions. Initial ones, not entirely related with oracles, but very basic stuff like there are no events, lack of doctrines in some functions, the error message might be unfriendly, so you might try to come up with a better one. If you have joined or watched the session about tokens, well, there is a token integration in there, so we should be thinking about what kind of tokens would work with this contract or not. There might be a reentrancy in there, perhaps something to dig deeper into. And then we see set oracle function, so somebody is probably allowed to set that oracle address. Who's that? And what's the process to set it, right? Again, you may have joined the access control session, and we cover lots of strategies to that kind of things. So we can start asking things about what's behind that only owner. What are those powers? Are those documented? What happens if ownership of the contract gets compromised, and so on, right? And there is one specific line that says Oracle get price. So let's see some more things about it. Just in one single line of Solidity code, we can ask many things. So I can start with what happens if the price is 0? What happens if the price is really, really large? What's the price unit actually returned by the Oracle? What happens if the price for an asset that you're querying is actually inverted? How many decimals? How's actually the price calculated in the Oracle? Does that matter for this case or not? There are oracles that do not allow you to read prices on chain if you have not been authorized. Can we do that in this case or not? How's the price updated in the Oracle? It might be the case that there are delays, or it might be the case that it's not updated as frequently as you might expect. Can the Oracle be even upgraded? Who can do that? How? When can they do it? There might be privileged rows in the Oracle with different kind of powers to change things. Perhaps this oracle is actually using a manipulable oracle. Are we taking that into account? Or perhaps the oracle can be shut down by some privileged accounts or by anyone, I don't know. Who can do it, when, how? And regardless of any of that, would it make sense for this contract to also use like a fallback oracle to make sure that something is in control in the worst case scenario? And probably many others, right? We can probably continue asking questions. So let's use many of these as triggers for what's to come. When we talk about this Solidity line that says Oracle get price, basically what we are trying to understand is two things: integrity of the Oracle and availability of the Oracle. That will get us an idea, a general idea around the security of the Oracle and how that can impact our system. So probably you want the perfect solution, right? Well, there is no perfect solution, that's clear. Sorry if you were expecting something, the silver bullet of oracles in this talk. But we can do something. We can talk about like understanding what are the risks of using different oracles and trying to make, to some extent, informed decisions around how we integrate safely with oracles and what kind of security considerations we should be taking into account, right? Again, no perfect solution, but we can at least take things seriously enough and carefully enough that everybody should be a little bit safer in the ecosystem. So let's see a common use of a price oracle, right? There are many, probably in DeFi, oracles are kind of a critical infrastructure and they might be used for many things. But let's see just one common case, right? So there's a presentation by Austin Williams, former researcher at OpenZeppelin, that you can find in our forum, which is called the Orwell collateralized loan pattern. I won't get into the details of it, but it's a way in which lending protocols implement loans of tokens, and they use a price oracle for many reasons, such as calculating a specific value, which is called the loan to value ratio. It's a formula. If you are not so familiar with it, don't worry. No need to fully understand it. I'm just saying that in DeFi, there are specific cases in which price oracles are fully required. For instance, they might be able to trigger or not liquidations in lending protocols, depending on what the price of an asset is. So they play like a fundamental role in DeFi in some cases. And what happens if these oracles get manipulated, right? So let's see like a very basic example from a very high level. Let's see we have a project that is selling keys and you pay in ETH and the contract will give away some keys, right? And the contract will actually use a price oracle to understand what's the price of the keys in ETH. So let's say that you are buying 10 keys, the contract will query an oracle and they will give away a certain number of keys as long as you have paid enough for them. That's fine. But what happens if the oracle gets compromised or is manipulated or something like that? It might be the case that the oracle says that the price of keys is 0 and basically now everyone can buy all keys from an oracle. And not only that, but that's also true for every other project depending on the same oracle. So as many projects depend on the same oracle, the security of the oracle is far more important. So that's kind of what could happen in DeFi if any of the oracles that we have today available gets compromised at some point. But we are not doomed, right? There are things that we can do about this. And there are alternatives. And these alternatives have many names, such as the price feed from Chainlink or Maker or Uniswap time-weighted average prices, or the open price feed from that Compound uses, and probably many other oracles, but those are kind of the known ones. And I should say something. There are strong communities behind each of these oracles and supporters behind each of them. And I will just be mentioning from my perspective, like security considerations when we are interacting with them. I'm far from trying to vouch for one or the other, and I'm not taking sides in the presentation, right? Because I know there's been like recent drama around some of these oracles, and I'm not interested in participating in any of that. I'm just trying to put together like educational content around how people should be able to interact with these oracles in a safer way. That's all I'm doing here, no taking sides. And also, if I'm not mentioning your favorite oracle, that will be in our place, not in this presentation. But anyway, having said that, let's start with Chainlink price feeds. Pretty well known, you have probably heard of them, and perhaps you're actually using them, and lots of people using Chainlink price feeds in their smart contracts. And let's see how they work and some ideas around them. So one thing that I should also mention before I jump into this is that these kind of things change very quickly. So it might be the case that I'm showing something for you today, and next week a new version comes up and the architecture or the addresses or the functions change. So this is last time I checked, which was this week. This is how it seems to work. So in Chainlink, we have multiple contracts deployed on chains that come up that made up the architecture, but there is one important one, which is called the access control of chain aggregator, that basically is a contract that is able to calculate the median price of a number of prices that get posted from an off-chain peer-to-peer network, right? This peer-to-peer network has its own consensus mechanism, and it's able to sign price data and to submit, it aggregates price data from multiple off-chain sources and submits it to this access control off-chain aggregator contract. In return, people will get paid for this. If you want to actually query this, you usually do this through the EIC aggregator proxy contract, which is basically like an interface contract, let's call it. So your DeFi project, for instance, will ask the EIC aggregator proxy contract how much is it in USD, and the proxy will be able to answer that question. Actually, the proxy will be like calling this access control off-chain aggregator to be able to know what the price is, right? And there is a pair for each of these contracts, depending on the price feed that you are querying, right? So far, so good. Reality tends to be like a little bit more complicated than that. And I won't get into all the details of this diagram that I'm slowly putting together, but let's see kind of some pieces of this that might be relevant. And actually, this is still simplified, right? So in reality, we have this, again, this is off-chain, we have these oracles in this network, and that for each pair will be a different subset of oracles and different number and so on and so forth. But they will sign a single report and they will submit that report on chain, and the access control off-chain aggregator has this transmit function that they will be able to call and put the price on chain. There are many other mechanics in here, but let's just focus on these ones. So one thing to notice is that you won't be able to read the price directly from the access control off-chain aggregator, but because it has some access controls in place. So from your contracts, you won't be able to call that. But you can call that from, you can communicate with the EIC aggregator proxy. And the EIC aggregator proxy has some functions, we are about to see those, that you can actually query, and it's open, and you can directly integrate that into your contracts. But there are some additional components to this story, which are these, right? So we see some multisigs and EOAs and access controllers and so on. And it's interesting to think that, well, they have some powers in the architecture of Chainlink, and it might make sense for these powers to be there. I'm not against those powers. So having said that, I think there is room for more, let's say, documentation around these powers of these accounts, but we are about to get to that. So if you want to query prices from this EIC aggregator proxy, what you want to do is, there are two ways. One is the deprecated one, is the previous version. One is the latest one that I have seen. So there is this function like latest raw data that you can query or get raw data to get historical prices. And the deprecated ones are the ones that you see there. But it might be the case that these functions are a little bit more complicated than that. In the first two, in all of them, actually, there might be a place in which these functions might not work as you would expect. And in the deprecated ones also, one of them like returns a zero price, but it's deprecated, so I don't want to focus on that. But let's go a little bit deeper this scenario of service that I'm talking about. So I show you that we have these accounts that have powers over this architecture, right? So what happens if one of these multisigs, that it's like a 3 and 14 multisig, decides to remove access from this interface to the aggregator, right? What would happen in that case is exactly this. These functions would revert immediately, and there is no time lock and there is no governance as long as I have seen for that. So I'm not saying that the owners of this multisig will do that, right? Because there's like a position they have in the ecosystem, and I'm sure they won't do that. But it might be a case that keys get compromised, right? So one attack that these attackers compromising keys could do is just cut the access from the contracts that you are actually querying to the access control of chain aggregator, and that might be problematic. Or there are more sophisticated cases in which they could like introduce access controller contracts or other things, which might be more sophisticated and more difficult to realize and might be problematic. And probably in these diagrams, there are many other roles and powers. And again, I'm not against that. I'm only saying that I haven't seen this too much documented, and I would like to see at some point, yeah, more documentation and more information about the exact powers of these accounts and what they can do, so we can all be protected, right? So I told you that, well, in the case that if this interface, which is the aggregator proxy, cannot access the aggregator, well, these functions would revert. So you can actually protect against that. It's not that complicated. You can use try catch. So at the top, you see for the new interface, like the recommended one, we see that we are querying the latest round data function, but just using try catch. And you use try catch, and if everything fails, you can at least handle the error safely, and you can do something else with it. And in the bottom, you see a similar pattern, but with the previous one. So you see that this is like the duplicated one, but still I've seen people in the wild doing this. So you can actually use the try catch, and within the try catch, you can use the if to check whether the price is 0 or not. And in this case, it might be the case that you need, I don't know, to use a fallback oracle, which some people use, such as Abbe, for example. And all other things, right? You can actually revert because you are actually like explicitly handling that failure and so on. So there are things that you can do. So some recommendations from high level, right? We shouldn't assume that this oracle is like fully centralized and permissionless. I would say it's like a distributed thing, but there are roles, there are powers, and we should be verifying that. We are at the end of the day, we are trusting some off-chain operators and multisigs, and that might be fine as long as you are like consciously doing that. We have ways to code defensively to protect against some threats in case private keys get compromised. Obviously, we shouldn't be using deprecated interface. Depending on the interfaces, we should be checking whether prices can be 0 or not. And we should also be always checking units and decimals for the price fits. And this is true for many of the cases that we are about to see, right? So some of these recommendations might also apply for the next oracles that I'm about to cover. So that's all for Chainlink. Let's continue with the open price feed. The open price feed actually is used by, is kind of a framework to some extent built by Compound. It's open source, it's there to be used, but today it's mostly used by the Compound protocol. So it's today, I mean, it's been changing many versions of it, but today it basically has this contract called the Uniswap Anchor View. I should be saying that I should be answering questions at the end of the presentation. So this Uniswap Anchor View is kind of the core contract of it. And basically what's going on today, because this has been changing, but the current version is that some Chainlink contracts are able to post asset prices to this Uniswap Anchor View. And this view will actually, depending on what's the price of that asset in Uniswap, will kind of anchor the price and will set like upper bounds and lower bounds. So the price that is posted from Chainlink can deviate to a certain extent from the anchor that is set by Uniswap. So there is like some room for flexibility, which is nice. But there are questions about this, right? So how does Chainlink post the prices? Are there privileged rows in this view? How's the price actually calculated? Who sets the bounds? So let's start with Chainlink. So today, what I have seen is that, remember that I talked about this access control of chain aggregator that has this transmit function? Well, every time that transmit function is called in some of the price feeds, and that contract will actually communicate through this function, which is called validate answer, to some validator proxy. And this validator proxy in turn will call, because that's the interface, a function that is called validate, which, regardless of its name, actually posts the prices to the Uniswap Anchor View. And similar considerations regarding owners and privileged accounts apply for this case as well. In the case specifically for the view, we see that there is a multisig held by the Compound community that has a way to activate and deactivate what they call the failover mode. The failover mode is basically a way to disregard whatever is being posted from, in this case, the chain price feeds. And it will only, once you activate the failover mode, the view will only take into account prices coming from the Uniswap V2 pool. And this multisig can actually activate and deactivate that. How's the price calculated? Basically, it's using, we are going to be talking about the time-weighted average prices from Uniswap, so don't worry, but it's using that. And it's calculating that over what they call like a lagging window between 30 and 60 minutes. And for the bounds, these bounds are set on deployment, are immutable, like it's basically a percentage of the anchor price for the upper and lower bound. And it's interesting to know that these bounds are the same for all of the views. I mean, the view can get you access to many assets, but these upper bounds or lower bounds apply for all of them. So if you want to read a price, you have two ways. You can use the price function that returns the value in USD with 6 decimals. And there is another function that you can pass the address of a C token, and it will get you the price of the underlying token, right? And that's the one that actually Compound's controller uses. You can go to Compound's controller contract, which is deployed in mainnet, and you can see this in action. And difference between those functions is that one returns the price with 6 decimals and the other returns the price with 18 decimals. And so we should be careful with that. Some remarks, some considerations for the open price feed. So, as I said, Chainlink today is powering this kind of architecture. Previously was powered by, I think, that Coinbase at some point. But anyway, today the powers of Chainlink in this case are to some extent limited by this TWAP anchor. That might be better for some cases, for some scenarios, and not so better for others, such as, for example, let's say that in a period of high volatility of prices, the anchor might be too slow to move. So in that case, limiting the powers might not be the best, but in other cases, it might be cool. I mentioned the failover mode. You should be careful when the oracle is in failover mode, because it might be the case that the price is outdated. So you need to update it first. You can read documentation about it. I mentioned that the periods and the bounds are the same for all assets. That might be good at some moments, that might not be better at some other moments, depending on the volatility of the price of the asset, right? But today, that's what we have. We should be careful again with the amount of decimals, depends on the function that we are querying. Remember that these queries will revert depending on whether we are querying supported or unsupported symbols or C tokens. Something interesting also to note is that in this oracle, the prices for USDT, TUSD, and USDC are not reported. They are just set to 1 USD. Which might be more efficient if everything goes well, but if at some point any of those assets loses the peg, it might not be the best scenario, but there might be ways to solve that. And I should mention also that this oracle has been like evolving a lot. So it's something to consider, to be always up to date with what's going on. Because usually after the upgrades in the Compound protocol, which is the main user, it might be the case that some views get outdated or unreported, and that has happened. So you should be careful. Just be up to date with what's going on if you're integrating with this oracle. Lots of things. I told you this would be pretty packed and lots of content, and we might go over the usual 40 minutes. So, turn to talk about Uniswap time-weighted average prices. I like this. I think that it's a nice way of getting prices in a, to some extent, safe way, but they also have their weaknesses, right? Everything that I'm telling you today have strengths and weaknesses. Hopefully, that's the impression that you will get as well. So, the way to not query prices, if you're querying Uniswap, and not using their time-weighted average prices, is basically just taking the ratio between the assets that are held in a pool, right? So this is, for some people might be pretty obvious, but for some other people might not be so obvious. So just take into account, I have links and resources at the end of the end of the talk, sorry, where you can read more about this. But this is what you shouldn't be doing, right? Taking the ratio in the balances of the Uniswap pools and calculating the price for that, just because they can be super easily manipulated. So in Uniswap V2, there is an interesting mechanic, which is the time-weighted average price, that allows you, I mean, internally, I should be saying the pool in Uniswap V2 is tracking what they call the cumulative price, right? So every time, I think that in every block, they will be tracking what's the cumulative price. And what you can do with that is actually check what's the cumulative price at one point, check what's the cumulative price, I don't know, 1 hour later. You should be doing that in your own contracts for the period that you want, and then calculate what's the time-weighted average price with this very simple formula, right? There's more about it to calculate it in the Uniswap documentation, but one thing to note is that obviously, to some extent, the security of using this oracle will also depend on, first, ensuring that people that are arbitraging these pools are making them like in an efficient and effective way, but also taking into consideration that the period should be like to some extent long enough so that the prices cannot be manipulated cheaply. So if you want to do that, you can query any Uniswap V2 pair. It has two functions. One is for what they call the price 0 cumulative last and the price 1 cumulative last. Basically, the idea is you have two accumulators tracking the prices of token A in regards to token B or token B in regards to token A. So depending on which one you want, you should be querying one of these functions. Something to note is that the cumulative price is in fixed point notation. So the price that you will receive, you will need to do some math to actually change it to the units that you need. Again, there's more about it if you want to read in Uniswap's documentation. And if you actually want to use this, and there are examples of this, right? So you can start by using the Uniswap V2 Oracle library, which is kind of a wrapper that will let you do some of the math and the queries in an easier way. That's available, that's open source, you can use it. I've seen it used. You can see an example of a 24-hour time-weighted average price using Uniswap V2. And again, it's available, so if you want like a real example provided by Uniswap, it's there and you can use it. And you can take inspiration from it. And actually, I mentioned at the beginning that, well, the open price feed is actually using this mechanic. So you can actually check the code of the open price feed, and you will actually see this fetch enterprise and pop Windows value functions where they implement this lagging window mechanism, which is quite interesting, and you can check it to use Uniswap V2 time-weighted average prices. So the question would be, oh, sorry, no, this. So some remarks and considerations before we move to this question. So first one is something that I already mentioned. There is kind of a trade-off in between ease of manipulation and the accuracy of the time-weighted average prices, right? So if you go with a very, very short period of time, it might be the case that it's easier to manipulate. But if you go with a longer period of time, it might be more difficult to manipulate. But on the other hand, in periods of high price volatility, it might not be so accurate. So, I mean, it might be even slow to respond, and that might be problematic in some DeFi protocols. So there is kind of a trade-off in there. That's something that comes with these types of protocols. In Uniswap V2, you should be careful that the time-weighted average price of A in B is not the reciprocal of B in A, just because they are using the arithmetic mean. You can. I'm not getting into the details of the math of it, but be careful with that. I've seen errors coming from that. So that's why you have two different accumulators. So you should be querying the one that you need. Don't do the reciprocal of the price that you get recklessly. Again, you should be aware of the units and the decimals of the return prices. We see as auditor lots of issues coming from people not taking into account different amount of decimals and the units of these prices. So be careful with that. There are available libraries, I mentioned that. And again, if you want more details, you have the documentation, and also in the audit for the V2, there is like a specific section by the auditors outlining many other recommendations in terms of security for these oracles. And now for the question, what about Uniswap v3? Well, things change a little bit in Uniswap v3, not so much, but it's a little bit, I think, to some extent more efficient. And let's see why. In Uniswap v3, we no longer have checkpoints of accumulators. These checkpoints are kind of already embedded in the pools, so you don't need to like put additional logic into your contracts. It's far easier than that. And now you can actually use the reciprocal of the prices just because they're using the geometric mean instead of the arithmetic mean. And there are like practical and theoretical reasons for that. You can read the white paper of V3. There's like lots of content and specific things about that. And if you want to go to specific, you will see that the actual accumulator is tracking kind of the sum of the logarithm of the prices for some additional reasons that I won't get into details. If you don't want to read anything of that, I mean, you should be reading anything of that if you're integrating with this, but well, there are libraries that can help you query this. For simple implementations, there is this Oracle library that you can use. And you can basically pass the address of the pool and the period of time that you want to use to calculate, and you can get the time-weighted average price. The time-weighted average tick, which is different from the price, because you actually need to transform that, and I won't get into the details of that, but there is a way to deriving the actual price. So again, be careful with these kind of things. And also make sure that you are querying for a period that to some extent makes sense, because if you query for longer periods of time, this function will just plainly revert. There's some internal mechanics for that in Uniswap v3 that you may or not be able to query, I don't know, at the time-weighted average price of some pool for 30 minutes, 15 minutes, 10 minutes, or days, depending on the specific pool. Again, you can read the documentation for the details. So some things to take into account, right? We shouldn't be just calling these functions and expecting everything to work magically. There is work to do on your side. And errors in this kind of cases might end up resulting, and we have seen that in security, big security issues. So last but not least, maker oracles. I should start saying that, well, not everyone has access to these on-chain oracles, right? There is a way in which you need to kind of sign up to these on-chain price feeds. So that means that you will need to go through some formal process of being able to be whitelisted and be able to read from these feeds. So if you're using this, I would initially assume that, well, you are already going through that process. So you are already getting familiar with the system and you are not using them like out of the blue recklessly without taking into account some of these security considerations that I'm about to show you. So that's why I may not go into too much detail in this case. But we are about to see some things interesting. So maker oracles. There are different ways, but this is kind of the main one. Let's see what this is about. So there are two main contracts, the median and the OSM. The OSM is the short for Oracle Security Module, I guess. So the median is a contract similar to what we saw earlier in Chainlink, in that there are like people posting prices, and this contract will calculate the median of it. And I think that the similarities end in that place. But we have this off-chain peer-to-peer network. I think they call it Scuttlebutt, which is a funny name. They have different roles in there, like feeds and relayers that will gather prices from off-chain sources and will be able to post prices to the median contract, right? And then we have this OSM contract that is able to, using the funny names of maker, to pick into the median and get the price of it. why does the OSM actually exist? Well, the OSM that anyone can call this poke function to update it. The OSM exposes delayed prices, and that means that if you query the OSM now, you will see that there are actually two prices, one which is the current one and one that is the price that is about to be set in an hour, for example. So that means that updates to the OSM price oracle will take at least for an hour to be able to be reflected in the OSM. And they have included that like for security reasons, right? So having those delays in some scenarios might be good, in some scenarios might not. But the main reason, I guess, is giving time for people to react to changes in the prices, right? So once you see an update, you know that in the next hour, you should be doing something, for instance, with your loans in your lending protocols, because you know that with the next price, you might be liquidated. So you should be taking that into consideration. There is like a delay in this OSM. And if you want to read from these contracts, remember, you should be whitelisted. And if you're not whitelisted, or if you're whitelisted and you are removed from the whitelist, the queries will just revert. So remember that. But on top of that, you should be taking into account that there are different functions to it, right? So your whitelisted contract might read from the median or might read from the OSM. There are functions to read from them. In the median, you have read and pick. Depending on which one you query, one returns a Boolean flag and the other one returns a revert, and depending on where the price is actually set or not. So again, be careful with those little subtleties in that. And as I mentioned in Chainlink, in this case, there are also like privileged accounts that can remove you from the whitelist. So if you are removed from the whitelist, you will no longer be able to read from these contracts. And in the case of the OSM, we also have an additional function which is called pip. And with pip, you can actually query what's the next price that is about to be set in the oracle. One thing that I should mention about this is that at least from my view, I have seen this far more well documented than in other cases. So if you go to Maker's documentation, you will see like lots of caveats and security considerations and like explicit documentation stating many of these powers and edge cases that you should be taking into account. So in that sense, I think that it's better than in other cases. So talking about outstanding powers, right? So there are ways to allow and disallow price readers and writers from these oracles, from these contracts. In the median, you will see previous accounts able to change the threshold on that is needed to update the price. Or in the OSM, you might be seeing functions that can stop the contract, or that can change the delay, or that can delete prices. So you should be able to understand the subtleties of these things and be able to assess where this introduces additional risks or not into your protocol, right? And many of these changes might also be going through Maker's governance. So there are ways. But I mentioned that, well, the median and the OSM are not the only ones, right? So Maker has additional oracles, such as the UniV2LP oracle and the DS value, that they use, one for the Uniswap V2LP tokens, obviously, and the other one for stablecoins. So let's go with the, again, all of this is open source. I'm not saying something that is confidential. Everything is for you to read and for you to make your own research about these kind of things. So in the case of the UniV2LP oracle, what you will find is, again, you should be whitelisted and similar functions as in the other case, right? And it's interesting to know that in this contract, it's kind of, it has an OSM to some extent built into a contract, so that the prices are also delayed. And if you're interested in seeing how they calculate the value of LP tokens in Uniswap, this might be like a good way to see if it makes sense. And well, additionally, you should be poking this contract to make it so that the price gets updated when you need it. In the case of the DS value, which is the name of the contract that they are using to post prices and bid prices of stable coins, any contract. I haven't seen white lists in the DS value and that I've seen deployed, but some of them might have. I'm not exactly sure, but from what I've seen, it's any contract. So again, similar functions for reading, and depending whether you want the revert functionality or the Boolean flag, it's up to you. And the DS value has this poke function that an authorized account can call, which is, from what I have seen in some instances, a time lock contract. And then privileged accounts will probably be able to schedule things in the time lock, and the time lock will be able to update these oracles for stablecoins. Very well. So that's, I think, for Maker, and for Chainlink, and for the compound private, and for Uniswap V2 and V3. So closing thoughts. We are just wrapping up. Hopefully you're here with me still. It's weird to be talking with and not seeing anyone. So closing thoughts for this. Again, we covered many cases and this changes a lot. So take this with a pinch of salt, just because tomorrow many of these interfaces and mechanics and architectures can change. But well, the first one is there's clearly no silver bullet. And there are trade-offs and strengths and weaknesses in many of the oracles that we have covered. And probably there are other oracle architectures that I haven't covered in this talk. And all of them will probably have, again, security considerations to take into account. To some extent, or to different extents, in any of them, you have seen that, well, there might be owners, nodes, operators, or even if there are no kind of privileged accounts, in some cases, we are even trusting that there are people arbitraging pools so that the price is actually up to date and reflecting like the real market price. I've shown you some ways of applying like defensive coding, for instance, using try catch in many of these cases, or like checking the decimals, or checking units, or querying the accumulators that you need. So there are ways of defending against many of the, to some extent, threats that these oracles may present. I've covered like delays and fallback oracles, and those might be able to also reduce risks. I've seen projects in mainnet, for instance, using fallback oracles, and that means that if the main oracle that they are querying for some reason is not functioning, they just fall back to their own oracle, which could be in some scenarios useful. Oracles are a little thing, and probably it's been pretty clear by now. And many of them are open. You can participate, you can join the discussions, you can contribute, you can make them better if you don't like them. And you should be able to stay up to date with what's going on. Again, strong communities for many of these oracles, and you can participate and contribute and highlight things if you don't like them, or try to improve them in many ways, or just use them and support them in that way. But be careful, they are a living thing and they evolve as many living things. And the final one is you should be reading, you should be learning, and you should be taking better informed decisions and conscious decisions when you integrate with price oracles. Hopefully this talk has helped to some extent shed some light into some of the subtleties and mechanics that many oracles have. And you will be a little bit more paranoid. I'm not saying not use them. I mean, they are super useful and are a critical infrastructure, so we should be able to use them, but in a safe and sustainable way to some extent. And again, many of the things that I have talked to you is just me reading documentation and going to white papers and reading deployments in mainnet and verify source codes. There is no magic in here, right? It's just the information is there, and you can use it to take better decisions around it. So you want to learn more, probably. So these are some of the links that I can share with you. In the Ethereum official page you have, in the community Maker, there are like frequently asked questions around oracles. Uniswap has good documentation. There is lots of material from Chainlink as well in the community that I'm not including here because there is a lot from it, and you can read that as well. I'm not mentioning other approaches to oracles, such as the one that Yuma is using, which is super interesting, and they call it like the priceless contracts that they use. So if you want to read other approaches to oracles, you have a link in there, and some resources from who else? Samsung. That will also help you like take better decisions around how you integrate with oracles. And probably I'm missing many links in here, I know that. So, well, we have covered the dangers of price oracles. Long session today, but I think that it was insightful and hopefully with content that was very useful for you. For the next ones, we have at least 2, but there will be a last one, which I'm already thinking about. We will have secure smart contract upgrades. We will cover many of the pitfalls around upgrades and how to do them safely. And also the perils of low-level code. Again, there are many ways of screwing up Solidity contracts using assembly or using low-level codes from Solidity. So we will cover many of those edge cases in that talk. In the meantime, you can read Advisor and you can read many on the links that I was showing earlier, these links. And for Advisor, you will find an OpenZeppelin Defender is the product that we have for secure smart contract operations. You will find that we have a component called Advisor, and you will find lots of articles around security considerations and recommendations when building a smart contract. So I recommend you read those. As Huichi said at the beginning, we are hiring many open roles. Hopefully, if you want to participate in any of these kind of things, you can join us and you can help build a more secure ecosystem with us. And that's it. Thank you very much. Now we will open for questions. We have more than 50 people in here, so you might raise hands or send your questions in the chat. Probably, I don't know if we will have time to answer everything, but just drop them. If you want to reach out, you can find me in Twitter. You can shoot me an email if you are the old school. And for learning more, you can check out Defender from OpenZeppelin. You can read our blog. You can go to the forum. Yep, we keep in touch and see you in the next session. And we'll go to the questions now.